This is Arif ERKOCA, founder of Ashlar STEM Academy. Today we will talk about the proof of Pythagorean Theorem, which is widely used in science and engineering. There are actually a lot of proofs of this theorem, but today I just want to present you the one that was published by the 20th US President James Abram Garfield. So James Abram Garfield was a politician and also a mathematician. So let's start with the proof. So all we need to do is to draw a right triangle. Here we go. It's my right triangle. So let's assume that this side length is A and this is B. So these are different. And this angle is alpha. This is beta. Here we go. This is our right triangle. And let's assume that this is named as A, B, and O. So these are the corners. So all we need to do now is put it a little bit up here. So we are gonna play with this triangle a little bit. So let's form another triangle, which is gonna be kind of a rotated version. So this side length would be B this time, and this will be A. So let's see, this is A. So this is the exact same triangle, but a rotated version. So this is like 90 degrees, okay? So now let's call this point, this vertex, to be O prime. And this angle this time would be alpha. And this angle would be beta. So let's call this to be B prime. So what we see here is, if we connect these 2 points, B prime and A, we form a trapezoid. So O prime, B prime, A, and O. So this is like a trapezoid. So let's work out the angles a little bit. So alpha plus beta should be 90 degrees due to the sum of internal angles of a triangle, right? So 90 plus alpha plus beta must be 180. So alpha plus beta must be 90. So alpha plus beta is 90. So this angle should actually be 90 degrees. You see that? So now let's call this side length as C. So this is C. So C is also nothing but the hypotenuse of OBA triangle, right triangle, right? So A, B, and C are the side lengths of O, A, and B triangle. Okay, so now here comes the proof. So let's calculate the area of this trapezoid. So it's actually simple. So the area calculation from the equation of a area of a trapezoid. So the base is B and the top is A. The height is A plus B. So A plus B, the bottom plus the top sides, times the height, which is A plus B, divided by 2. So this is the area. So there is also another way of calculating the area, right? So now we have, as you see, 1, 2, and 3 right triangles. So this area should be also equal to the area of the first triangle, which is A times B divided by 2, plus C times C divided by 2, so C squared divided by 2, plus A times B divided by 2. This is the area of the third triangle. Here we go. So now we have these areas, right? So these two areas should be equal to each other, which is the area of the trapezoid, right? So now let's equate these two expressions. Okay, so we can do it on the side here. So a plus b squared divided by 2. So this is simply equal to a squared plus 2ab plus b squared divided by 2. So this should be equal to, so ab over 2 plus ab over 2, so I have two of those. So it's simply a times b. So I have a times b plus c squared over 2. Okay. So I can simplify it by multiplying with 2 both sides. So this is simply equal to a squared plus 2ab plus b squared is equal to, so multiplying by 2, 2ab plus c squared. So we see something really nice here. So 2ab and 2ab, they cancel each other out. So in the end, what we have is a squared plus b squared is equal to c squared. And thanks to James Abram GARFIELD, 20th US president, is also a mathematician, who actually presented this proof to us. So this proof actually tells us that if you have a right triangle with side lengths a and b, this is a, this is b, the hypotenuse is c, and then c squared is equal to a squared plus b squared. And this is what the Pythagorean theorem says. So if you have any questions, please reach us out at ashlar@ashlarstem.com. You can also visit our website www.ashlarstem.com. Thanks for watching. See you in the next episode. Bye.